Calculating maximum demand for non-domestic installations. The same principle of load groups and allocations apply in this table, but the load types and current allocations will differ. So let's look at C 2.4.2.1 and remember, each phase is its own installation for maximum demand calculations. As this installation is a motel complex, we will be using column 2 of table C2 for current allocations of loads. By this time, the principles of balancing loads across phases should be understood. As in previous examples, load group A is calculated first. 2 phases will have a loading of 13.7 amps and the third 11.74 amps. 10 exhaust fans per phase add another 1.63 amps to load group A. When we arrive at load group B, loading allocation for 10 amp socket outlets will depend on where they are installed. Areas having heating or cooling equipment attract 1000 watts for the first outlet, then 100 watts for each additional outlet per phase. Where heating and cooling equipment is not included in the area, current allocation is 1000 watts for the first outlet, then 400 watts for each additional outlet per phase. 5 outlets in load group B1 are placed in 2 phases, with a loading of 11.3 amps per phase. Load group B2 is spread over all 3 phases, with 30 outlets per phase giving a loading of 16.96 amps. Load group B3 allocates the full load of the first outlet and 50% of the remainder per phase. 2 phases will be allocated 15 amps and the third 22.5 amps. The 3-phase range in load group C is split over 3 phases, with 1 element group in each phase. As there is only 1 element per phase, the load allocation is 100%. This gives loads of 28.7 amps, 21.74 amps and 21.74 amps. The 3-phase pump in load group D contributes full load current at 2 amps per phase. Finally, load group G has a single-phase sauna with a full load rating allocation of 26.09 amps. When all phase loadings are added up, we find the highest loaded phase has a value of 95.16 amps.